In this future world, we can expect to see everything, from 4D printing to flying autonomous vehicles. Let's take a journey into the future and explore these 20 amazing technologies that will blow your mind. 1. DNA computing. DNA computing involves using biology instead of silicon to solve complex problems. When one DNA strand links to another, it triggers a reaction that modifies another short DNA sequence. This action-reaction process mirrors the organic way humans think, which is a fundamental aspect of how most of our computers are built. Currently, we're quite far from having anything usable in DNA computing. We have only managed to create the most basic Turing machine, which involves creating a set of rules, providing an input, and getting a specific output based on those rules. In practical terms, we've been able to play tic-tac-toe with DNA, a feat that's both disheartening and impressive. 2. Smart dust. Smart dust refers to a collection of incredibly tiny sensors that can gather large amounts of data, including light, vibrations, and temperature, over a vast area. These systems can theoretically transmit this information to a server or analysis systems via a wireless computer network. Potential applications include detecting pipe corrosion before leaks occur, tracking mass movements in cities, and monitoring climate change over extensive areas. However, there are concerns with this technology. Potential ecological harm caused by these sensors and the possibility of their use for unethical purposes are significant issues. Additionally, we are far from being able to implement such technology in the near future. Communicating with devices of such small size is challenging, and smart dust could be vulnerable to environmental conditions and microwaves. Number 3. 4D printing. A 4D printed product is a 3D printed object that can alter its properties when exposed to specific stimuli such as submersion underwater, heating, or shaking. The potential applications are still under discussion. However, promising fields include healthcare, with pills that activate only when the body reaches a certain temperature, fashion, with clothes that tighten in cold temperatures, and homemaking, with furniture that becomes rigid under certain stimuli. A significant challenge for this technology is identifying suitable components for various applications. While some progress has been made, we are far from having a product ready for consumers, as we still need to master the reversible changes of certain materials. 4. Neuromorphic hardware. Neuromorphic engineering is a fascinating field at the intersection of biology, physics, mathematics, computer science, and electronic engineering. Its goal is to create hardware that mirrors the behavior of neurons in response to sensory inputs. Unlike DNA computing, which uses organic matter to create computers, neuromorphic hardware uses silicon to replicate neurons and synapses. This approach is gaining significance as we approach the limits of the exponential growth in computing power predicted by Moore's law due to quantum mechanics constraints. As a result, we need to explore new methods for quick computations. 5. Nanoscale 3D printing. 3D printing is a technology still seeking its full potential. One reason is that 3D printers remain too costly for the average consumer and aren't yet efficient or fast enough for large-scale manufacturers. However, this could change in the coming decades. Researchers have developed a method that uses a laser to speed up the 3D printing process significantly, while maintaining high-quality results. Current applications focus on flexible electronics and micro-optics, but rapid advancements in both liquid and solid materials suggest that the ability to construct small yet complex structures is on the horizon. Number 6. Digital twins. Unlike some of the other technologies discussed in this video, digital twins are already being implemented and may not directly affect you. Essentially, digital twins combine artificial intelligence, machine learning, and software analytics to create a digital replica of physical assets that updates as its physical counterpart changes. They provide information throughout an object's life cycle and can assist in testing new functionalities of a physical object. Expect significant news on this topic from the manufacturing, automotive, and healthcare industries. 7. Volumetric displays. Volumetric displays, which are basically holograms, can be created using 3 current techniques. These include illuminating spinning surfaces, illuminating gases, or illuminating particles in the air. The use of these displays in advertising could be highly entertaining or quite problematic due to potential impracticalities. 8. Brain-computer interface. A brain-computer interface creates a direct communication path between an augmented brain and an external device. Despite the significant potential in prosthetics, the medical implications are arguably the most transformative. A chip implanted in the brain could prevent motion sickness, detect and diagnose cancer cells, and aid in the rehabilitation of stroke victims. Additionally, it could be utilized for marketing, entertainment, and education. Number 9. Zero-knowledge proof. Computer scientists are fervently working on the development of an advanced cryptographic tool. This unique tool holds the potential to provide a means of proof without the necessity of revealing the underlying information. This innovation is a testament to the ingenuity of modern computer science, showcasing a sophisticated solution to a complex problem. 10. Flying autonomous vehicles. This concept has long been a part of our collective imagination: flying cars. Naturally, there are many challenges associated with this sci-fi idea. We're already struggling with issues around conventional autonomous cars, so it's uncertain if flying cars will ever become a reality. Another problem is that our infrastructure is designed for traditional vehicles. Roads, buildings, parking, insurance, and licenses would all need to be overhauled. It's probable that flying cars will not become a reality unless society undergoes a significant transformation. Number 11. Smart robots. The concept of mixing robotics with advanced artificial intelligence, allowing the digital world to become physical, has been a staple of sci-fi for years. However, before this can become reality, we must improve robotic movement and pioneer a new AI research branch to address the multitude of reactions required for this technology to function. Autonomous mobile robots will also need robust batteries, fueling current research into lithium-silicon technologies. While we may not see Terminators soon, such autonomous robots are already appearing in warehouses, picking your Amazon orders, and on the streets, delivering groceries. 12. Quantum Internet. Quantum computing will enable us to dramatically increase the number of computations a computer can perform per second. A consequence of this is that no password will be safe in a quantum world, as it could become possible to test all potential text and number combinations in record time. In response to this modern problem, researchers at Delft University of Technology in the Netherlands are developing a quantum internet infrastructure. In this system, communications are encoded in the form of qubits and intertwined in photons, light, traveling through optical fibers. This makes them impossible to decrypt without disturbing the network. In simpler terms, any attempt to eavesdrop or hack the network would disrupt the communication and render it unintelligible. Data in this state is inherently impossible to observe without altering it. Number 13. Hyper-personalized medicine. Hyper-personalized medicine is an emerging technology with much potential. Essentially, it's genetic medicine tailor-made for individual patients, enabling the treatment of previously incurable or rare diseases. 14. Bioprinting. Bioprinting is a process that creates cellular structures using 3D printing techniques, where cellular functionality is preserved. Typically, 3D bioprinting employs a layer-by-layer approach to deposit materials, often referred to as bioinks. These create structures similar to natural biological tissues and are used in medical engineering fields. However, various challenges exist. Our understanding of the human body isn't sufficient for safe implementation of these techniques. Additionally, the costs are high, and the printed cells have a short lifespan. Ethical questions surrounding this technology also need to be addressed. Despite these challenges, the potential applications of bioprinting are vast and worth exploring. 15. Anti-aging drugs. Several treatments aimed at slowing or reversing aging are currently being tested. These treatments focus on halting the aging of cells associated with age and minimizing inflammation, which contributes to the accumulation of toxic substances and degenerative diseases such as Alzheimer's, cancer, and cardiovascular diseases. The goal is not to cure aging, but rather to enhance immune functions in older individuals. 16. Miniature AI. Due to AI's complexity, The computational power needed to train its algorithms and achieve breakthroughs doubles every 3 to 4 months. These programs' dedicated computers also consume vast amounts of energy. Digital giants are now aiming to shrink AI technology to make it more accessible to the general public. Google Assistant and Siri, for instance, incorporate voice recognition systems on a smartphone chip. AI is also utilized in digital cameras, enabling automatic photo retouching by removing unwanted details or enhancing contrast. Localized AI is more privacy-friendly and eliminates any information transfer latency. Number 17. Hyperloop. Elon Musk's second appearance on this list underscores his unique brand of genius. His Hyperloop project involves an underground low-pressure tube through which capsules transport passengers and goods. The design eliminates both air and ground friction. The former is removed from the tube, while the latter is avoided by levitating the capsules via electromagnetic lift systems. The capsules are propelled by a magnetic field generated by linear induction motors regularly placed inside the tubes. Moreover, the Hyperloop can reach its top speed faster than a plane. This technology also offers benefits such as reduced pollution and noise. However, it requires building extensive tunnels, sometimes beneath cities, at a significant cost, $75 million per kilometer. Challenges include constructing a perfectly straight tunnel, removing all air from the tube, and ensuring passenger safety in case of accidents. 18. Space mining. Asteroids are rich in mineral resources, which leads to the concept of space mining. The theory is that we could capture these asteroids, extract the minerals, and sell them on Earth. Planets are also relevant to this topic. However, turning a profit from the final frontier proves to be quite complex. Challenges include the high cost of space exploration, the difficulty in locating suitable asteroids, and the challenge of landing on an asteroid moving lightning fast. These difficulties don't even touch upon potential trade disputes and space conflicts that could arise if two nations or companies target the same space rock. Number 19. Orbital solar power. An orbital solar power station is an artificial satellite built in high orbit. It uses microwave or laser power transmission to send solar energy to a large antenna on Earth. This energy could replace conventional polluting energy sources. The advantage of an orbital solar power plant is its constant exposure to the sun, undisturbed by day-night cycles, weather, and seasons. This concept has been around since 1968, but there are still significant barriers. The construction costs are high, and it can't compete with current energy sources unless we reduce launch costs. 20. Teleportation. Teleportation, or the idea of disappearing from one place and instantly reappearing in another, has been a popular concept for decades. However, we're discussing something a bit simpler here: quantum teleportation. This allows information to be shared almost instantaneously from one point to another, not physical matter. We're not referring to trivial pieces of information like a fish and chips recipe, but rather the composition of entire molecules. In the early 2000s, scientists succeeded in transferring particles of light, which have zero mass, over short distances. Further experiments in quantum entanglement led to the successful teleportation of the first complete atom. Consequently, we might expect the first complex organic molecules, such as DNA and proteins, to be teleported by 2050. In conclusion, technology tends to reflect society, mirroring both its positive and negative aspects. It's crucial to remember that technology is often value neutral. Its everyday use determines whether we are dealing with the next big thing. Thanks for watching, and make sure to hit the like button, subscribe, and put notifications on to stay updated on everything related to AI.